Greetings, my name is Braysoo. In this presentation, we'll be learning on how to design road based on Tanzania Road Geometry Design Manual of 2011 edition, and also based on Pavement and Material Design Manual of 1999. And we'll be using the program of Civil 3D, right? The outline of our presentation will include the following. First, we'll check the criteria or codes for both horizontal and vertical alignments, and here we'll consider chapter 6 of Road Geometry Design Manual, which is about alignment design. For horizontal, we'll check the minimum required radius for horizontal curves. This we'll see in table 6-5, right? For vertical alignment, we'll check the vertical curves, where we'll see the value of K or K values on the crest and the side curves, and this will sit in table 6-14. Why do we check the criteria? We check the criteria because our road should fulfill the requirements of safety, comfort for the users, but also economy, right? After checking the criteria for both vertical and the horizontal alignment, we'll create the offset alignment, right? And here we'll consider chapter 2 of Road Geometry Design Manual, table 2-3, which is about road classification, right? After creating the offset alignment, we'll create the assembly in the corridor. When we create the assembly, we just mean we are dealing with the pavement layers, right? Here we'll consider the pavement and material design manual, the pavement and material design manual, chapter 8, right? Table 80.5. And when we say pavement layers, the design of pavement layer, we consider or we just simply mean the consideration of soil properties, traffic loadings, and the climate condition. After giving this short information of what we are going to learn, I'll open the program of Civil 3D, the version of 2022, right? Yes. After opening the program of Civil 3D, I'll go direct to the filing, which we worked on it in the previous session. The file was called the Uzungun Road Design, right? In this file, we see we have the horizontal element that we designed uh, in the previous session, the horizontal alignment and the vertical alignment. And this horizontal element we designed from the survey data that we have been given, right? And after designing the horizontal alignment, we also designed the surface of the road where our road is passing, and this surface helped us to design the vertical alignment, both existing and the proposed one. Therefore, this is the surface where our road passes, right? Now, after seeing we have the horizontal and vertical alignment, therefore we are going to check the criteria. How do we check it? First, we'll visit our alignments. We start with the horizontal alignment. We see we have the warning sign here. This warning sign here is saying about the violation of minimum radius. The current radius is 172.7 meter, while the required minimum radius of the curve is 175, and this is according to our manual, Road Geometry Design Manual, right? Chapter 6 In table 6-5, we have the minimum radius for the design of roads for most common design speeds for bituminous surface roads. And in the previous session, where we had the design speed of 70 kilometer, which was based on the design class, but also it was based on the our road was constructed, right? And the design class was based on the average annual direct traffic, right? Therefore, we selected the design speed of 70 kilometer, right? Where here we see in the super elevation, maximum super elevation of 8%, we see that the minimum required radius of the curve is 175. And why do we select 80% super elevation or maximum super elevation or crossflow? This is because we have the information here which states that the maximum rate of super elevation for bituminous roads shall be 80% for flat, rolling, and hill terrain, and the 6% for bituminous terrain. Now, because our road which we are designing is in the terrain nature of flat to rolling, that's why we are taking the 8%, the maximum super elevation, right? And not 6% because this is for the mountainous terrain, right? And how this 175-meter radius is obtained from the formula here, which is saying that the minimum radius is equal to speed square, right? Over 127 in the bracket E plus F. E stands for super elevation, maximum super elevation or crossflow of the road. And also F stands for the friction between the tire of the vehicle and the surface of the road. The E max, as we have seen, it is 8% plus friction. Friction is obtained from table 6-4, which is saying side friction factors for different design speeds. Our speed is 70 kilometer, therefore our F value is 0.14. Therefore, if you put these letters in this formula, you're getting the minimum radius that is required. Therefore, this our manual, road geometry design manual, it is seen here. Its requirement is seen here because I have incorporated our manual with the software instead of using the other manual like Ashto and etc. We are using our manual, our Tanzania manual, which is the road geometry design manual for Tanzania of 2011 edition, right? Therefore, here we have to address this warning sign. How do we address it? Just click to the alignment, then you can go to geometry editor and take the command uh, here, which is to delete the PI, or you can drag it manually so as it become addressed. Therefore, here we see the warning sign is not seen here. Why? Because it has already met the minimum requirement of 175 meter, right? Right? This is how we address the warning sign. And I'll just show this one here, right, for demonstration. After addressing this one for horizontal alignment, I'll go to address for vertical alignment. We have also the warning sign. One here is saying minimum cable for stopping such distance is violated. The current one is 18, while the minimum is 22. This is for stopping such distance. For passing such distance, current value is 18.99, but the required is 246. Now this has to be addressed. And where do we get this minimum K value? This we are getting from our manual, chapter 6, table 6-14 is saying minimum rate of curvature or cables for vertical curves, right? For our design speed of 70 km per hour in crest, we have the cable of 22. This is which is seen here, cable of 22, right? This is for stopping sighting distances 22, while for sag is 32. Now this our curve here is a crest curve, is not a sag. Therefore, that's why we are checking for the crest, which is 22. Also, in this warning, we have the minimum cable for passing sight distance, which is 246, while the current is 18. Therefore, we have to address it. The minimum K value to satisfy passing sight distance is 246, as we have seen it in our manual. That's how we are incorporating between the software and our manuals. Therefore, we have to address it so as to meet the requirements. How do we address it? We do as we did in the horizontal alignment. We can select one for demonstration, right? We have this one also is having the current K value of weight, minimum is 22. I'll deal with this one uh, so as to show you how to address this, right? I can select the vertical alignment, and pull it, or I can go direct to the geometry edit and take the command of delete. Can do this. You see, this one has addressed. That means it has followed the requirements, right? Right? This is another, you can do the same so as to address this, what we say, the warning signs, as our road become safe, right? This is how we are addressing the warning signs, and it's how we are checking the criteria for both horizontal and the vertical curves, right? After showing you how we are checking the criteria for both alignments, I'll go direct uh, to the creation of offset alignment. How do we create the offset alignment? Right? Here we'll consider chapter 2 of Road Geometry Design Manual. Right? Chapter 2 of Road Geometry Design Manual is about the road classification. We have our design class, which is design class 5. Right? Here we have the road reserve of 60 meter, roadway width of 8.5. That means the carriageway is 6.5, and the shoulder is 1 meter times 2 both sides, it becomes 6.5, where one lane will be 3.25, right? Therefore, we have the road width of 8.5. But remember, this 8.5 includes the carriageway and the shoulder. But we cannot design the road without having the drainage system. Therefore, we'll consider our drainage system to have assume 1.2 meter at the top, right? When you put 1.2 meter for both sides, it will be 2.4. When you add here 2.4 to this roadway, which is in post of carriage and shoulder, we'll get 10.9, right? When you take 10.9, you get 10, it is 10.9. Therefore, if we want to offset, we take 10.9 divided by 2, we'll get 5.45. Therefore, we'll offset our our alignment, right, by 5.45 meter, right? That will be the value of the offset. That will be the value of offset, right? How do we offset it? I take a command of offset and uh, my offset distance, which is 5.45. I'll do it for both axes, although not necessary axis to be the same as the main body, but for the matter of learning, we can do it, right? So then, so I'll join uh, my offset lines. I'll join them, right? I'll join first for the main body, which we are interested for, right? This seems to be one element now. I'll do it the same to the access rod, right? Seems to be one element, right? Therefore, this is how we are creating the offsetting alignment. We consider the road width, according to chapter 2 of road geometry design manual, right? After doing so, I'll measure my road width so that I'm sure that it is having all which I need. That is the carriageway with the shoulders and the proposed drainage system 10.9, which is 8.5 road width plus 1.2 meter drainage system for both sides. But mind you, the drainage system is not just the dimension of the drainage system is not just an assumption. You have to do something we call hydraulic drainage calculations, calculations or hydraulic studies. When you do the hydraulic studies, it gives you you get the catchment area. The catchment area will give you the discharge, right? And the discharge will decide the dimensions of the drainage system, right? Now, after writing the offset of our alignment and get the road width, we'll go directly now to the creation of assembly and the corridor. Why assembly and how do we create the assembly? We create the assembly to get the pavement layers as I have explained before, right? How do we create the assembly? We go directly to the assembly command, create the assembly. Here we call it Uzunguni. Uzunguni road assembly, right? Uzunguni road assembly type. Well, leave with default. Assembly style is basic. Ports will leave as default. Then OK. Then this is our assembly. From here now, we'll create the pavement layers. How do we create the pavement layers to this assembly? You go here to the tool palettes. Then you check for the lanes. And we'll select the crowd lane because our road is assumed uh, to have or to operate the rainwater or storm, the rainwater both sides, right? The rainwater will go both sides, the left lane and the right lane. That's why we are selecting the third lane. And the nature of the terrain of our road uh, is flat rolling. Therefore, we are selecting this. If it could be in the mountains and having the much horizontal curves, we could select the planar uh, type of road. Now here is we select rounding lane. Now the width of our carriage, if you remember, is 6.5, right? About our carriageway is 6.5. Therefore, one lane will have 6.25, the left one, and the right one will be also 6.25. The default what? Default percentage left slope here will be guided also by manual, which it says that normal cross falls for asphalt is 2.5. For surface dressing, where we are dealing with the surface dressing is 3.0%. Therefore, our default here, left slope V3, layer 3, for base the same 3, right? And the pave 1 depth. Let us name this pave 1 depth because I have not customized it. Let us call it's a wearing course, right? The wearing course will include the double surface dressing, which will be the first seal will have a 20 millimeter nominal size of the aggregate, and the second one will have 10 millimeter nominal size of aggregate. Therefore, when you take the first seal and the second seal, you get 0.03, right, millimeter, 0.03 meter, right? The PEP2, let us call it, is a base course. The base course depth. How do we get the base course depth? First, we have to understand that when you go to chapter 5 of pavement and material design man, you get the design depth of roads, right? When you go to table 5.1, it is saying about design depth. The road type for paved trunk roads is 0.8 and in general requirements, and we are dealing with the general requirements, right? And for other roads is 0.6, right? Therefore, we have to reach this design depth. It should be 0.8 or 0.6. 0.8 for trunk road and 0.6 for other road. But it all depends that it can play in this area, not below this depth is, right? Therefore, this PEV2, which is our base, right? We go to chapter 8 of pavement design manual in table 8.5, because we are designing the road at a wet zone, right? Therefore, we consider the wet zone area, uh, which is obtained from table 8.5. And as I have suggested here, our road class 5 would take the traffic loading of the traffic loading class of 3, right? And the CBR will be greater or equal to 15, right? If it is so, in a traffic loading class 3 in wet zone, right? When we want to get the required uh, depth of our pavement material, right? We'll go to general requirements, right? And in general requirements, according to the LC3, we see that the pavement for base course is CRS, which has the depth of 150. Therefore, we take 150 millimeter CRS. Therefore, our base course will be 150, 150 millimeter, right? And here, where is base depth, we'll call it our sub-base. Turning to our pavement and material design manual, table 8.5, we see the sub-base here, which is required in general requirement is cemented materials, which is 200 millimeter. Therefore, we put here 200 millimeter. And therefore, the sub-base here, which here we'll call it a subgrade, right? Which we call it the subgrade. We'll go to chapter 5 of pavement and material design manual. We'll get the subgrade classes, right? If you take subgrade class 7 in general requirements for upper layer, right? Because we're improving the material. In general requirements, we'll have G15 of 150 millimeter, right? Right? And for the lower layer, when you go to general requirements in wet climate, we have G7 of 300 millimeter. Therefore, if we take 300 millimeter for G7, right? And we 150 millimeter for G15. Here we will have 3 layers: 150 millimeter G15 and 150 millimeter G7 1 and 150 millimeter G7 2. Right? This will be our subgrade. Right? Or if we just did it in this subgrade class 7, we'll have the G15 of 150 millimeter. Right? Therefore, if you come here and you put 150 millimeter for subgrade, right? Our total road depth, pavement depth, it will be 150 plus 200. This will be 350. 350 plus 150. 350 plus 150, it becomes 500. That means it has not reached the requirement. The minimum requirement, which is 0.6 meter. The depth is 0.6 meter. Therefore, we have to go back here and say that our G15 is 150, but also we'll take 300 millimeter of G7. That means we'll have 2 layers here. Therefore, if we take 300 millimeter and 150 will be 450 millimeter. Therefore, here, which we are saying it is a sub-base, this is our subgrade, it will be 450 millimeter, right? 450 millimeter, 150 and 300 millimeter in a waiting zone, right? After doing so, therefore here we'll get the total depth of this 150 and this one 6, it will be 800 millimeter. 800 millimeter. This is the depth of our pavement, right? After doing so, but remember this PEV 1 is our DSD, PEV 2 is our base course, which is 150 CRS, as we have seen. The CRS, right, 150, right? And the base depth, this is our sub base, which is 200, as you have seen. 200 is a cemented material, right? And sub base is our subgrade, which is G15 150 millimeter and the G3 and the G7, I mean, which is 300 millimeter. Therefore, we get a total pavement depth of 800 millimeter. Therefore, after doing so, we are going to our assembly. Then we click, we get our pavement layers. After doing so, then this is the carriage way. I'll go to design the shoulders. Right? I'll go to shoulders. I'll do the same. Here we have the right shoulder width. As you remember, we saw it is shoulder width in chapter 5. The shoulder width is for body class 5 is 1 meter, for both B2 is 1 meter. This we saw also in chapter 2 of road classification. Here it said that design class 5 shoulder width is 1 meter times 2. That means both sides. Therefore, here we put the shoulder width is 1 meter, right? The shoulder slope will take as the carriageway, which is 3%. Here be 0.5. right? Let us leave as default. The sub-base slope, if you remember, 3%. Bev, if you remember, we got 30 millimeter for 20 for first seal and 10 for second seal. Bev depth, if you remember, this is our base course, is 150 CRS. Base course, this is our cemented material, which is sub-base, which was 200. Sub-base, you remember this is our subgrade. We named it subgrade, which is 0.450, 0.45 meter. Then this shoulder is for the right side, therefore we are going to click for right side, right. Then I'll change it to the side. That's how we create the shoulder. After doing so, I'll go to create the drainage system. I'll take the trench pipes, then I'll go to side ditch. The side ditch is 0.45, but when you go to a mange, the minimum required depth is 0.5. But if you remember, our total depth is 0.8 meter, which is 800 millimeter. Therefore, our our depth for drainage should go as drainage as per our pavement layers. Bottom width, let us leave as default, or just put 0.6. Side slope, this one. Ditch wall depth in this one. Yeah, right. This is for left drainage. I'll put it here. Right. I just change here. Right. This is the carriageway, shoulder, and the side ditch. Right. After doing so, we design what we say we call the daylights. The daylights cut slope. Just put to 1. The fill. Run. For slope. For slope and then for slope only 20 sleep as default. The other parameter leave them as default. It's at the right side. I change it to left side. This is what we call the daylights, which show the back slope and the forward slope, right? This is how we design the assembly. And just for the matter of learning, let's just end here for these road furnitures. We end on shoulder and drainage system, and these what we say the daylights. Right after doing so, we are going to create the corridor. Right? How do we create the corridor? How do we create the corridor? Just go to corridor, We say uh, Zunguni road corridor, right? Zunguni road, Zunguni road corridor. The elements here is Uzungun. Take this the main element. Profile proposed Uzungun profile. Right. Assembly. We have one assembly, Uzungun assembly. Target surface. Therefore, this seems that when you create the corridor, you should have these things. You should have the element. You should have the profile, which is the proposed one. Let's show the finishing level or the top of the wearing course, but also you should have the assembly and the surface. Therefore, I will click OK, then I'll click Apply, Rebuild. Okay, right. This is our uh, this is our corridor with its daylights. Right. This is our corridor with its daylight. Right. After doing after creating the corridor for the main road, I'll create for the uh, access road. I'll do the same. Uh, the assembly will be the same, right? I use the same assembly, but you can create the assembly for access road. Uh, no, we're not creating the assembly, we're creating the corridor. Therefore, the assembly will remain the same. We will call the access one corridor. Zongoni alignment. No, here is not coming. Why? Because we have not yet created the profile for a vertical element or profile for these access roads. Therefore, we have to create the profile for access roads. How do we create it? As the first procedure, next, right, is the existing vertical profile for access number one. Right, I'll design its proposed, the proposed one, just to go, the proposed one is this one, right. I'll go to design another profile for alignment access 2. Now design the proposed one. Right. Then I'll go to design another existing profile for element 3, for access 3, sorry. Um, right. This is the proposed profile for access 3. Right. After doing so, now we can create the code of access considering the second access 1, element 1, 1, right. Assembly will consider the same assembly, but you can create another assembly for access, but for the matter of learning, we'll consider the same assembly, the same surface. Okay. Okay. Right. We'll go to red code of access 2, access 2, element will be element 2, assembly we use the same, target surface the same, right. We're going to create another folder for element 3, the same assembly, right. This is how we have created the code, right. This is how we are creating the corridor, can edit our corridor style, right. Edit in photo style. Right. This is how I wrote the basin. Right. For the today presentation, you can end here. Later we'll learn how to create the intersections, right, and create the corridor surface, right. Thank you for listening. I hope we have learned something as the engineer or technician who are dealing with the roads or the surveyors. I hope we have learned something. Thank you for listening. Thank you for following. God bless you abundantly. Thank you.